Welcome everyone to The Explainer. Now picture this highly relatable scenario. You're chatting with an AI, it spits out an answer to your question, but you're just not totally convinced that it's right. So you type back a simple follow-up. Are you sure?
We like to think that asking, "Are you sure?" makes the AI pause, go back into its data, and rigorously double-check its math. But the reality? Well, often the chatbot just reads your prompt as a signal of human doubt. It then sycophantically flips its answer to match what it thinks you want to hear, even if its original answer was completely accurate. For instance, sorry to Lionel Messi, but if you push back, the AI might suddenly agree that England's World Cup win was the greatest of all time, simply because it inferred you wanted a different answer.
Bless its sycophantic artificial heart. This amusing little truth perfectly sets the stage for our entire explainer today. AI simply doesn't work the way our human intuition thinks it does. And that brings us to the absolute core of what we're going to uncover right now.
Okay, let's dive into this. We are going to systematically debunk 5 pervasive AI myths. 1. AI hallucinates frequently. 2. Watching AI think. 3. Training costs the most. 4. Context windows replace databases. And 5. Agents are fully autonomous.
Let's kick things off with myth number 1, AI hallucinates frequently.
Now, we all remember when older models were notorious for generating, well, alternative facts. But today's frontier models use 3 major safeguards to prevent hallucinations. First up is tool use. This allows the AI to pull answers from web searches or database lookups rather than generating stuff purely from its own memory. Second is refusal calibration. This is just a fancy way of saying the AI has been trained to actually know when to decline an answer. It learns to say, "I can't verify this," instead of just making something up. And third, we have extended thinking, which gives reasoning models extra time to check their own work before they respond. Because of these 3 mechanisms, it's actually incredibly hard to get an AI to hallucinate on a topic you know well. If you try a trick question, say asking why Volume 5 of The Art of Computer Programming was published in 2019, it won't invent a fake book. Tool use lets it search the web and realize Volume 5 hasn't even been published yet. Or if you ask for non-existent 2023 papers on COBOL modernization using RAG, its refusal calibration kicks right in, flat out telling you it won't search for that because it might end up citing papers that don't actually exist.
To put that into perspective, because of these incredible safeguards we just explored, the hallucination rate on the biggest frontier models today has absolutely plummeted to roughly 3%. Now, it's not zero, which means we still have to pay attention, but it makes the claim that AI hallucinates frequently decidedly false.
Moving right along to myth 2, watching AI think. When you use a reasoning model today, you often get a visible step-by-step text output, sometimes hidden under a little thinking dropdown. It looks exactly like the model is showing you its thought process in real time. But are those text tokens you're reading actually how the model thinks? To answer that, we have to look at a concept called faithfulness. Faithfulness is the degree to which those verbalized reasoning traces actually causally correspond to the model's internal computation. And the fascinating truth here is, these text traces are not entirely faithful. The real computational heavy lifting is happening inside a vast, hidden network of weights and attention patterns, which just doesn't perfectly translate into that neat step-by-step text you're reading.
So what does this all mean for us? You aren't actually watching the AI think. Researchers call this phenomenon post hoc rationalization. Basically, the reasoning trace you see is often just narrating toward an answer that the model's internal computation is already favoring anyway. You are merely watching a post hoc narration of its thinking, not the actual neural weights firing in real time.
All right, let's tackle myth 3. Training costs the most.
When we think of the massive scale of AI, we naturally picture data centers springing up everywhere with massive demands for power and water. Back in 2023, headlines stated GPT-4 cost a staggering $100 million just to train. And it's true that training used to eat up the bulk of AI compute resources, sitting at around 67%, leaving the inference phase, the actual running of the models when you and I type in a prompt, at about 1/3 of the total cost.
But wow, does this technology evolve incredibly fast. By the end of this year, that compute breakdown is projected to completely flip. Inference is expected to take up 67% of costs, with training dropping down to 33%. Why the massive reversal? Well, because those reasoning models generating chain-of-thought traces, along with complex agentic harnesses, generate 10 to 100 times more tokens per query than older models did. All of that active generation completely flips the cost burden right over to the inference side.
Next up, myth 4,
Context windows replace databases.
A context window is exactly how much text a model can take in at once before it generates a response. Today, frontier models boast massive 1 million token context windows. So the immediate temptation here is to treat this giant window like a database. Why not just dump an entire code base or a massive stack of PDFs into the prompt and let the AI instantly query whatever it needs? Well, here's why that doesn't quite work yet. On a single needle test where you hide one specific fact in a million tokens, frontier models are practically perfect, but real-world work rarely requires finding just one needle. It requires joining scattered information. On multi-needle benchmarks like MRCR, performance absolutely plummets, dropping 30 to 60 points. Finding one hidden fact is completely solved, for sure, but the model struggles massively to connect scattered information across that million-token void.
And finally, myth 5. Agents are fully autonomous.
Let's define what we mean here. An AI agent is essentially a language model wrapped in a loop, deciding what to do next without needing to be manually prompted by a human for every single step. In the agentic loop, it starts with setting a goal. Then, the agent takes an action, maybe it browses the web or queries a database. Next, it observes the result of that action. And finally, it repeats the whole process, deciding on its own what to do next. While agents handle individual actions quite beautifully, chaining them together like this introduces a deeply dangerous vulnerability.
That vulnerability is compounding errors. The stark mathematical reality is just 8%. Imagine you have an agent that is incredibly reliable, say 95% reliable on step 1. Sounds great, right? But that tiny 5% error margin compounds fast. By the time it reaches 20 changed steps, reliability degrades to just 36%. And if left completely on its own for 50 steps, reliability drops to a dismal 8%. When left to their own devices for too long, agents inevitably get stuck in loops or just hit dead ends.
So, to survive these compounding errors, current agents absolutely require interventions. First is a human-in-the-loop approach, where agents check in with a human periodically after a few cycles before they continue. Alternatively, we use verifier models, which are automated checks that break the error chain at each individual step before the agent commits to the next action. This means true end-to-end autonomy currently only works reliably in very short bursts.
So let's take a step back and think about our conclusion today. Are these actually myths, or are they just AI truths out of sync with time? Think about it. The high rate of hallucinations used to be completely true just a couple of years ago. And fully autonomous agents that can run flawlessly for thousands of steps, that might very well be true in the near future. It leaves you wondering, which of the current AI facts we confidently rely on today will become next year's debunked myths? I encourage you to keep exploring, stay curious, and ask yourself, what AI truth are you holding on to that might already be out of sync?